Math 35. This is really like our second day of math lecture. God damn it. Keeps beeping at me. I'm gonna try to fix it. Yeah,
That's nice.
I'm really good at it, aren't I? Isn't that a good fix? Let's see. Motherfucker. I'm just gonna have to edit out the first 2 minutes of the video.
That's what that would have. That's good.
First step to fixing any electronic thing, about to restart that bastard. Almost always works. Now I can't book that shit. Problem solving, baby. That's how you do it. Solve that shit. So where were we? Math 35, day 2. We are still in R2. So we'll call this R2b. We were doing some evaluating expressions the other day. Maybe I'll give you one more just to make sure everyone's on board. Evaluating expressions. We are going to use it today. So let's say like A equals 2 and B equals -3. And we want to evaluate 4a squared b minus 2ab squared. A good way to do it is just replace everything that's got a variable with a parenthesis sign first. And leave your exponents on the outside stuff because it will hit the negatives if you plug them in. So A was 2 and B was -3. Then we follow PEMDAS. Please excuse my dumbass sibling. I need to change that. I could probably get away with my dumbass students. I might get in trouble if I go with that. Someone's gonna bitch and complain, acting like I'm targeting them. And I could just go, no, it's someone from another class. But still, someone's gonna be upset, so we'll stick with students.
Students.
Siblings, my bad, siblings. So we do this, parentheses, there's no action going on. Exponents come next. Having something like A parentheses B is the same, I already have A and B here. X parentheses Y is the same thing as X times Y. So the parentheses just separate. They're another way of having multiplication. Without like, what?
No.
You're good?
I asked my own question.
That's good. You gotta like when that happens. So the 2 squared is 4. And I could just switch right to it right now. I'm gonna leave the -3 in parentheses because if I don't, I might confuse that negative sign with some shit. And -3 squared. When you have a negative number and you raise it to any even power, it becomes positive. So -3 times -3 is +9. We're supposed to go left to right. So let's go left to right. I just don't like multiplying 16 times -3. And this is gonna be 4 times 9. 16 times -3 is -48.
Excuse me.
Yeah,
I'm not seeing. I'm using your computer's background in the.
interesting. Let me. I'm glad you said something. No one else did. Oh, Hannah did. Sorry, guys. There we go. Hey, Lynn, you guys waited too long. Let's give them a minute to write that shit out.
Now I can see it. Thank you.
Cool. Go ahead and take a second to copy it down and we'll continue on.
Okay. I came a little bit late. This is the first page you're writing, right?
It is the first page, yeah.
Okay, let me take.
So Darian, guess what? Your home slice over here, Luis, was so bored or so interested in Hefe. He showed up at fucking 2:30 when my office hours started and was waiting outside my door damn near. Almost outside my door. He was like 30 feet from my door.
Oh, what time?
2:30.
2:30.
Said, how you doing, Mr. Jones? Can I chat with you for a while? And he had no math questions. He just wanted to hang out with Hefe. What kind of fucking nerd hangs out with their math teacher? Right? I didn't hang out with my fucking math teachers when I was a student.
He's trying to get on your good side. That's the plan. That's what it is.
He already had that. Any student that walks into a math class and says they want to letter their math major, they're already on your good side. It's like a dying breed. There's so few of us. So he may not have any fucking interest in mathematics whatsoever. If he doesn't, he's really fucking skilled at this math. Because first he's leaved in with the fucking I want to be a math major, then he's just fucking hanging out before class starts. It's bullshit. I did at a couple of points hang out with teachers, but it was like when we went on field trips and like we were staying overnight, and so we go to like a pool hall and play pool and shit and stuff like that. All right, you guys, are you ready online? Does anyone need a little bit longer to write this down? Okay, some more stuff we're gonna do. That's gonna pop up throughout the class. Evaluating expressions. This is never going away. We're gonna do it all the time. In fact, this is our main form of checking work. Checking your work, this is what we're gonna do. We're gonna evaluate expressions. That's how we'll do it, and I'll show you when we get there. But this also, this whole area was also on algebraic expressions. So let's do a little bit more with manipulating algebraic expressions. Let's say we have 7 minus 2 times x plus y. The first problem is finished. We got -48. I didn't finish. I stopped talking. And I looked down and just saw a number and I'm like, nope, we're done. That's good. Thank you. Oddly enough, this is how I do this problem. I'm not going to pull out a calculator. I'm going to pull 4 off of that -48 and put it with the -36. This becomes -44 and minus 40, and I get -84. That is how I do mathematics in my head. I pull from the other numbers to make it so I get a number that ends with a 0 and makes math really fucking easy at that point. So -84 is the final answer. If you put it in a calculator or like worked it out, you should have gotten that value. All right, algebraic expressions, some things we can do. Oh, I do want to continue with this. What values did I have for x and y that I want to use here? X is 2, y is -1, z is -4. It's 2, y is -1, and z is -4. So let's just say we have that for now. I want to make it very, very clear right now, we cannot do 7 minus 2 first. Equals 5. This does not equal 5 times x plus y. And I will show you why when we work it out by plugging in the stuff, how it's different. So let's go back and let's plug in what we got. X was 2 and y was -1. I'm always using parentheses when I plug stuff in. Maybe I'll make it in a different color so it's clear that I was substituting in. We got to do PEMDAS. Parentheses happen first. This has got to happen first. 2 plus -1 is 1. And I still have 7 minus 2 parentheses 1. What? Huh? What? Who? This is the same thing as 7 minus 2 times 1. The reason why we don't put I could have had a multiplication sign out there, but it just makes more writing. So mathematics don't do it. This ends up being 7 minus 2 times 1, which is 7 minus 2. We would do multiplication before division. And I end up with 5. This is not a good example to show you why we don't do this. 7 minus 2, it's gonna get the same answer. I just realized it's gonna get the same answer, so it's coincidence. Let me show it to you on the next. We got x equals 2 still, just copying that stuff down to the next page. Let's do five minus 2 times x minus 5 squared all over, oh no, let's add some too. Let's do add 4y. And then we're gonna put it all over z plus 5.
Is that z equals -4? Yes.
That is z equals -4, correct. Darian, did you know Luis before this class? Are you guys friends?
I knew him my senior year. He's a year younger than I.
Is it you're younger than you? Okay. So you guys don't hang out outside of class? Because you should tell his friends that he fucking hangs out with his math teacher.
He never wants it.
He thinks he's too cool for you?
Yeah.
Pray.
He's always been done.
What a nerd. Fucking with him. You can learn right away. You can learn pretty quickly. It's students that you can get away with, bantering with. If he wasn't smiling all the fucking time, I would never have sent him in. So that's what it started with day one. Just fucking kept looking over at Darian like Darian's his boy toy or some shit. Kept running away. No judgment, don't care what you're interested in. So no, I don't smile at my friends that much. All right, let's plug some shit in. I'm gonna replace everything. I'm gonna write everything down that was not a variable in black. And then I'm gonna plug shit in red. X was 2. Y is -1, and Z is -4. And my fraction bar didn't go far enough. If I can get in trouble this semester, I know I know. I got tenure, fuck it, I don't care. Alright, so remember when we got a fraction bar, there's like some unspoken parentheses here. They weren't shown, but fraction bar really implies it. We have to do what's on top separately of what's on bottom. So, well, the bottom actually is pretty easy. If we do the bottom, what's the bottom? It's 1. So like if we're dividing by 1, we don't even need the bottom anymore, right? Dividing by 1 is just the same number. So like just looking at that straight away, without even doing anything else, I've made it look prettier. What?
I didn't know this is.
Off the screen. Did I? Everything looks right.
Maybe.
Okay. So now I don't even need that parentheses thing because I dealt with the bottom. So we look at, we're following PEMDAS still, don't forget that shit. So the next one is exponents. So 5 minus 2. Two minus 5 is -3. And yeah, there we go. So I did what's inside the parentheses. Now I got to address the exponent. I crossed off parentheses button earlier like a champ. -3 squared is 9. Getting too caught up in harassing one of my students and making mistakes. All right, so here's an example of why we don't do that 5 minus 2 first. If I did 5 minus 2 parentheses 9, if I did this first, I'd have 3 times 9, and I would get 27. Let's see what we really get from this set right here. 2 times 9 is 18. So I have 5 minus 18, and then 4 times -1 is -4. And having a plus and a minus like this is just the same thing as saying -4. So I'm going to show that real quick, just so that everyone's on the same page. Plus and negative is the same thing as addition. Or another way of saying that is subtraction is the same as adding a negative, adding the negative. Now, if I go left to right and I do that 5 minus 18, I get -13 minus 4, and I put them together and I get -17. That's the correct answer. If I had done the 5 minus 2 first, this negative 13 would have been there as a 27. It's the wrong number. And the reason why is there is an unspoken multiplication there. So even though it doesn't show the multiplication, you gotta remember, a number in front of parentheses is like having multiplication. Any questions? Now time to get
Just give me a minute, sorry.
Yeah. Oh, so you're phoning in from Hanford, aren't you? You're out there?
What happened?
You're from Hanford, right?
I'm from no, I'm from Visalia.
Oh, I wonder why I had Hanford in my head.
Yeah,
Can't be
yeah.
perfect, right?
I'm taking this online because actually it's far away. It's like 25 minutes driving.
Oh yeah,
Okay.
I understand why.
Yeah.
As long as you're here and taking notes and you show up for the tests, I don't mind if you're not here.
Okay.
It helps that you actually speak up on camera when you have a question, like, why the fuck can't I see your work, Mr. Jones? That's pretty fucking helpful. Like if you hadn't said anything, Hannah typed it, but I don't know how long it would have taken for me to see Hannah's chat message. And this video would have fucking sucked ass.
Yeah, online work for me right now, but like before, like COVID-19, it did pretty bad for me. But right now it's fine.
Oh yeah, we didn't do a lot of Zooming lectures or online lectures then. All right, everyone ready? I will assume so. This is the part that Luis is the wait for. He asked me, are we going to be writing a bunch more shit today? And I told him no, but we might have a little bit. I don't even know if I said that. I think I just lied to him and said no. But we are. We're going to talk about the properties of real numbers. And it's kind of important because they're the basis of everything that we do. Some of them are fucking stupid. But I want to start off and with it saying, we're going to let the letters A, B, and C represent real numbers. They are variables that represent real numbers. Now, if you go down the pure mathematics line, if you want to be a math person, say you're in this class, you're interested in math, you're going to see some shit like this. The first property is called closure. The closure property. If A and B are real, then A plus B is real also. And so is A minus B. Stimulating, isn't it? You start off with two real numbers and you put them together, they don't magically turn into an imaginary number. That's a real property that I'm supposed to share with you. That's not even the best one. There's more. There's great. These are great. You're gonna be happy to write these down. Commutative is not bad. We do use it. It's again, the commutative property is a no shit kind of property. Like you say, you're like, no shit. Of course it is. The commutative property says A plus B is the same as B plus A. It also applies to multiplication. A times B is the same as B times A. A lot of these are for adding or multiplying. but not subtraction and division. So if you want to see a quick example. 2 plus 3 is the same thing as 3 plus 2. 2 times 3 is the same thing as 3 times 2. That's just an example. That's not a proof. You want to do proofs, take real analysis at the university. I don't think anyone really wants a proof here. I don't even think Luis does. He might be one of those sick math people. We'll see. The jury's still out on Luis. That's commutative property. It's got the word commute in it. And commute means to like travel. And so we can see these things are traveling around. You can move them around. That's one way of remembering it. I'm not going to ask you what the names of these properties are. So only if you're a math major will you ever really care about many of these names. But the properties, the way they work, are important. Name, not so much. 3 is the associative property. A plus B plus C. We can add A and B together first, or we can add B and C together first. The same works with multiplication. I can multiply A and B first, or I can multiply B and C first. But the final outcome is the same. I actually use these in the thing I just did a little bit ago with doing -48 equals -44, -40, and changing around what I added. I was using some of these properties without naming them or anything like that. This is one of my favorites. It's so good. I'm going to do it in red. It's called identity. This shit is good. A plus 0 is the same as 0 plus A, which is A. This is called the additive identity. And the multiplicative, which is it is a fun word to say, multiplicative identity, has the same idea. It ends with an A. What do I gotta multiply A by to end with itself? No, 1. A times 1 is the same as 1 times A, which is A. This is shit you all hopefully knew. You just probably didn't call it the identity. Another fun one is the inverse identity. Not inverse identity, just inverse. For every real number A, there is a unique real number, -A, such that when I add them together, they equal 0. Or I could do them in the other order, -A plus A. That's the additive inverse. Additive. And just so you see how it's spelled out, because it sounds funny, multiplicative. Looks like multiplication, but it has an IVE. The multiplicative inverse is A times 1 over A equals 1. Or I can do the 1 over a first. And multiply by a.
Are we allowed to know the names of the adjustments?
Nope. God, that would make this class horrible. I don't remember the names of some of the most basic theorems. Teachers spit about like this, that, the mean value theorem, I know the mean value theorem, I know the mean intermediate value theorem, but there's a lot of theorems. I gotta look it up. I know what all the theorems do, I don't know what they are by name. I apparently don't give enough shit about history. Mean value isn't even named, most of the theorems later on are named after people. Which makes it harder. Theorems that haven't are named after what they do are a lot easier to remember. Mean value has a mean in it, which is an average. It's easy to remember. We got a couple more. You guys ready? Trying to not go too fast. The reason why we couldn't do the other shit earlier, well, not really the reason why. Number 6 is the distributive property. A times B plus C is the same as A times B plus A times C. And this works with subtraction as well. A times B minus C equals A times B minus A times C. The only reason you wouldn't combine B and C first is if one of them was a variable. At least one was a variable. If you want to see it in action, 2 times 3 plus 4 equals 2 times 3 plus 2 times 4. The left side is 2 times 7, and this is 6 plus 8. On both sides, we get 14. And now, one of the most used properties in all of algebra is the multiplication property of 0. Zero times A is the same as A times 0, which equals 0. And you would be like, wow, that's dumb. We will actually use this property later on in a non-intuitive way. The way we're going to use it is if we have A times B equals 0, either A equals 0 or B equals 0. So we take advantage of it. One of them has to equal 0. There are no two other numbers that multiply together that equal 0. At least one. They can both be 0. That's it for the fun name rules. We use a lot of these rules to simplify. And sometimes solve. Equations. One example of simplifying. Let's say we start off with 4/7 times 14x. This is like the way it looks right now is like A times B times C. And instead, we can do A times B first and then times C. So I can rewrite this as 4/7 times 14, and the X is on the outside. I'm only showing it so that it looks like a formula. I wouldn't actually do it like this. I would just multiply the 4/7 and the 14. 14. 4 times, or 14 and the 7 simplified sum. 14/7 is 2. This is 7 times 2. And the 7's cancel, and I'm left with 4 times 2x, which is 8x. So that's the simplified form. Do 2 more of this, like these example ideas. Wait a second, people are still writing. No, GNC healthcare or concoction you can make that's like meth or anything, something good. Like something like way better than ginseng and shit like that.
That's still worth that.
Could have used it.
The chocolate would help out a lot with that.
What?
The chocolate.
All right, you guys ready for more? Okay. Something that may not be intuitive. This is like having a -1 out front. And so we can use that distribution property, the distributive property. I can do -1 times m, which is -1m. And I can do -1 times -n. And when we have a 1 out front, we don't say it. This is just -m. And the two negatives make a positive here, -m plus n. The reason why we don't say a 1 is we don't do it in pretty much any language. I didn't drive 1 car to work today. If I said I drove 1 car to work today, you all think I was a fucking moron. I just drove a car or my car. The only time we list a number is if it's more than 1. Otherwise, if you list an object, it's assumed to be 1 when there's no number listed. Like if I ate a candy bar, you know that it's just 1 candy bar. You're not gonna go, was it 3 or 4? You know? If you did, I'd fucking feel a little judged. So something handy here is noticing if we multiply by a negative, all this did was change the signs. Positive n became negative n, and negative n became positive n. When you multiply by a negative, that's the kind of magic that you get.
So that would just be your answer negative.
Yeah. Without knowing what m and n are, we can't combine them. So we can only combine variables if we know what they are. 4x plus 20. This looks like 4 times x plus 4 times 5, if I rewrite it. rewrite the 20 as 4 times 5. And now this looks like a distributive thing. When I get the same number multiplied by two things added together, I can write this as 4 times x plus 5. This is called factoring. All right, some other things we need to know in this class. Again, we're still talking about real numbers. A number line. We can have a number line. Numbers to the right are higher than the numbers on the left. Numbers on the left are lower. Way we say that in mathematics is greater than and less than. And we have a symbol for that because that's a lot of words. The greater than uses this symbol, and less than uses this symbol. So I could say here, I could say A is less than B because it's to the left of it. So A is less than B. Equivalently, I could also say B is greater than A. So B is greater than A. If you have problems remembering how these work, put teeth on that motherfucker. This is a vampire. And it always goes after chases the bigger meal. So B is greater than A, the vampire wants to eat B. Or Pac-Man. We could have Pac-Man. I don't know how many of you fucking even know who Pac-Man. There was a movie up not too many years ago that had a fucking like 50-foot Pac-Man going down the streets of the town. What was that called?
Pixels.
Pixels. You guys both blew that shit out fast. You like that shit. Out of town. It's probably dead. Got some popcorn. Good times. I didn't start that one, Reese. Jimmy going throwing under you on the bus now. There's nothing wrong with that. No, you're not throwing him under the bus. There's nothing wrong with watching movies with friends. Oh, it doesn't sound like Luis likes hanging out with Darian, so like it sounds like more like a one-sided friendship. Like Darian wants to hang out with Luis and he. What?
I didn't even say pixels.
Oh, you didn't? Oh, shit. When I looked up, you two were looking at each other. When I looked up, you two were looking at each other. No one was looking at Drew. So I don't know. Yeah, but it was pixels. That's a fucking lame game. Although that's like some of the original AI.
What those Pong? So like.
No, the Pong, the ones that, I guess the thing's got to track the ball. I guess it does. Way too young to fucking know Pong. I had Pong, although just a little Pong game that it wasn't a cartridge or anything. It was just the whole fucking game. And you hooked it up to the TV, and you had two little controllers, and you spin the controllers to move the Pong, and it was just like playing tennis. Not really. You had a line to represent your racket, and you just had to move your line up and down to block the ball. In case you didn't know what Pong was. I'm surprised anyone in here did. All right, onward. Oh, something else I could say here. Since A is less than B, and that's my and sign, that's my and. B is less than C, we could put these together. And we can say A is less than B, which is less than C. The and part, if it's done correctly, lets us do the sandwich. As you'll see later on. Ready? Right. That's what you're gonna do. Absolute value, no fucking shame. No shame. I don't give a shit. You should see my wife in a fucking restaurant. Apparently, I make a face when I'm getting ready to fart, and she knows it. And so we're like sitting in a restaurant, and she could just, I think my face just like it stopped smiling, stopped talking for a second. That might be it. I just fucking shut up finally. She immediately goes, no, don't. And I just cringed. No, you fucking didn't. I did. Yeah, I did. She gets so embarrassed, like, no one can fucking smell it. If they could, it's someone else. It's a fucking waitress. That's right. No one's ever come to me and said, did you just fart while I was eating? Other than my wife. Absolute values. So the absolute value represents Does anybody in here know this? You all know what it does.
How far away it is from zero?
Fuck yeah! Go carry it. It represents the distance from zero of a number. Were you gonna say the same thing back there?
Yeah.
Awesome. Holy shit. Are you sure you're not a math major too?
No, I just remember it.
That's some fucking Jeopardy shit right there. All right, so like we got 0 here, and now we got -2 to the left, and we got 2 to the right. Both of these have a distance of 2 from 0. And the way we show absolute value is with big vertical bars. So the absolute value of -2 is the same thing as the absolute value of 2, which is 2. Now, what most of you will just remember this shit as is make it positive. That's what it boils down to, but it is the distance from 0. Distance is non-negative. It took me a while to appreciate the phrase non-negative. Like in my head, what do you think of when you hear non-negative? Positive. I'm like, why the fuck are you not just saying positive? Because 0 is non-negative, but it's not positive either. Zero's sign-wise, yeah. But 0 is a valid distance, but it's not positive. So like I'm 0 distance from myself. Sounds fucking stupid when you say it. But that's why they use non-negative sometimes. So properties of absolute value. Since it's non-negative, absolute value is always greater than or equal to. When we have a line underneath it, I should finish saying that, greater than or equal to 0. This means greater than or equal to. You'd think they'd be nice and would have made it something like this. But they're rat bastards. Not the same thing. You could technically write it where it looks like an equal sign with a fucking alligator on it. Or a vampire on it. So absolute value is A, if A is greater than or equal to 0, that's the whole non-negative thing. We already showed that it's the same thing as positive A. Multiplication works. We can distribute absolute value signs. So if you do the A times B on the inside, it's the same thing as A times B on the outside. Not the same for A plus B. These are not the same. No, no, no. Because if B is negative, it changes the whole thing. Or one of them is negative. In fact, we do have something that has this. What is true? Absolute value of A plus B and how it relates to the absolute value of A and the absolute value of B is it's always less than or equal to it. This actually has a name. It's called the triangle inequality. Maybe you'll see in trigonometry where we do triangles and shit. So let's just do one example with these. Has anyone in here not worked with absolute values before? Let me phrase this. Raise your hand if you've worked with absolute values before.
Me.
Everyone's good? So one example's good. Thanks, that's good. Hannah, are you? I don't even know if Hannah's on there. I need to keep the participant window up. Let's say A equals 4 and B equals -10. We can do 4 times -10. That's my A times B. We can show that's the same thing as 4 times -10 like that. We're testing out that multiplication one right here. Four times -10 is -40. And -10, oh, I haven't dealt with the absolute value signs yet. Now I'll deal with the absolute value signs, just turn everything inside positive. Forty equals 4 times 10. Related to this, the distance between 2 points, distance from P to Q, point P to point Q. At least on a number line. They often use abbreviated something like this. Put D and say P, Q. Let's say this has the value A, where A is a number and this equals B, where B is a number. We can write the distance as the absolute value of B minus A, which is identical to the absolute value of A minus B. Distance is the absolute value of the difference. And the order doesn't matter if you have the absolute value signs. If you don't have the absolute value signs, order matters. Without absolute value signs, the correct way is B minus A. That's without absolute value signs. Because you want to do the larger number minus the bigger number. Larger number minus the smaller number. That didn't make sense the first way I said it. All right, let's take a 5-minute break and we'll dive into R3. It's on polynomials. Some good shit going on in there. You're gonna like it.
Yes.
What? Hey, look, you're supposed to get food before 2:30. Why are you hanging out with your fucking math teacher? Nerd. All right, so this is gonna be for R3. What are we still on? Day 2? Day 2 of lecture. This is R3 and it's on polynomials. We kind of got to start off the rules for polynomials with the rules of exponents. So for these, we're going to assume A does not equal 0. That looks, how about I use B? B does not equal 0. B looks like a B. Kind of looks like a fucking 6, doesn't it? Let's go with C. C does not equal 0. There we go. C doesn't look like any number. So we have the product rule. C to the m power times C to the n power is C to the m plus n. That's a loud sigh. Are we hating it already?
No.
Not that bad. But
So I just need to breathe. Good to breathe. Breathe.
gotta remember to do that.
It helps.
Yes. All right, so the power rule that we're gonna do next has 4 variants, or 3 variants, because I know how to count to 3. Power rule 1 is A to the m power raised to the n power. Fuck, I did A again. This is C. God damn it. Let's just try this again. C to the m power raised to the n power is C to the m times n. Power rule number 2. Let's say f times g to the m power. We distribute it. F to the m power, g to the m power. Number 3. We have division, f over g raised to the n power is f to the n power over g to the n power. So here f doesn't equal 0 and g doesn't equal 0 either. The 0 exponent rule. I will show you how it works using the previous one, and you can deduce what it means if you don't already know. If I have c to the n and I multiply it by c to the 0, I'm going to use that product rule up there, and I have c to the n plus 0. So I used that rule right there. But n plus 0 is just n. So what does c to the 0 have to equal? It's got to equal 1, right? Because we have c to the n here, we got c to the n here, and we got something multiplying, it's got to equal 1. So the 0 exponent rule is anything raised to the 0 power equals 1. Except for c equals 0. You'll look at 0 to the 0 in calculus. We did things multiplied together. Maybe we should do the division ones. I assume I think I don't have the right number. This may not be R1, R2, R3. I might have to change the due dates on it work. I think the R1, R2, R3 was from a different book and I carried it over. I need to double check. I might be doing shit that's not related to the. This might be R4 as far as I fucking know. If I have f to the m over f to the n. This equals f to the m minus n. And we have something that we use interchangeably. X to the negative n equals 1 over x to the n. And I could say x to the n equals 1 over x to the negative n. Those two rules kind of go together. You can change the exponent sign by moving it to the other side of the fraction. Up or down, depending on where you're at. I'm off the screen. Those are all the fun rules of exponents. You will use them a lot from here on. Get comfortable with them. We're gonna do a bunch of examples here. Anybody need this up longer? Yeah. Give me it.
I have a question.
Yeah.
When would you need to change the exponent to a negative, like how you did on the bottom?
Usually we're going the other way.
That's what I
If we
figured.
have a negative exponent on the bottom, we're gonna move it to the top.
Oh, okay.
So like, that's a pretty good question about equal signs. This means identically the same thing as 1/x to the negative n equals x to the n. They're interchangeable.
Mhm.
So I wasn't saying start at a positive one and go to the negative one.
Oh, okay. Thank you.
That's a good question. All right. You good? All right, I got the thumbs up. We're good to go. So let's do some examples. We've got x to the 5th times x to the 8th. Which equals, when we're multiplying them, it turns into adding them. 5 plus 8 is 13. I could show you why. It might help. X to the 5th power is like writing this. And x to the 8th power is like writing this. I wish I hadn't chosen 5 and 5 and 8 for this example. So there's 5 here. There's 8 here. And that means there's 13 x's there total. So, x to 13. Guys ready for more? We're gonna have 3x squared, and we're gonna multiply it by 2x cubed. And we're gonna multiply that by 4x to the 5th. We talked about the commutative property of multiplication. This is technically 3 times x squared times 2 times x cubed times 4 times x to the 5th power. And we're going to commute some shit around. We're going to move all the numbers up front. Three times 2 times 4 is 24. And I have x to the 2 plus 3 plus 5. Which is 24x to the 10th power. Eventually, you don't write out this shit when you're learning it, until you're like comfortable. When you're comfortable, you could start here and jump over here. But if you do it on a test and you do it wrong, you're gonna be fucked for all of the points. So like on the first test, especially where we're doing all this shit, you might want to show out what you can. Partial credit is a real deal in mathematics. That'll save you a lot of points. Any question? Yeah.
If on a test we do that, if the answer is correct, we just skip a few of the steps, like 1 or 2, just to.
If your answer is correct, as long as you didn't skip too many steps, I'm good. Like as long as you got some, and that just depends on the problem. This one, you could go straight to it. If you're comfortable doing it, this was a simple enough thing in the grand scheme of things.
If it's a more complex one.
There are other ones where like too many steps is starting to look like you fucking photomapped that shit while I wasn't looking. Just because I'm old as fuck doesn't mean I don't know about this shit, guys. All right, we're gonna have 3 to the 4th power x squared, and we're gonna raise all that to the 3rd power. So when we have exponents on the outside and exponents on the inside, we multiply them by what's inside. This becomes 3 to the 4th power times the 3. And x to the 2nd power times the 3 is also. Becomes 3 to the 12th power, x to the 6th power. I'm afraid to look to see what 3 to the 12th power is. That's a big fucking number. 2 to the 12th power is a big number. What is it? Does it even give you a number?
It gave me a number, yeah. 531,000.
That's it? That seems too low. No way. Holy shit, that's not that high at all. I figure it's in the millions, or at least billions, maybe. Stuff like that. What are we gonna do here? Ooh. Let me give you guys one to try. Let me try to fucking confuse the shit out of you. That's my job, to make you go, why am I taking this class, Mr. Jones? I don't know what the fuck you're doing. That's not really my job, but we're gonna pretend it is for a moment. Because I'm a sadistic fuck.
That would be transferred,
What?
12x6.
So, yeah, that's the final one.
That's fine.
I wouldn't write that. You could write the 530 whatever thousand thing. But like, at some point you're like, it's too much fucking work. I'm lazy. You couldn't tell. Go for it. Try to figure this one out. Try it. We showed that you distribute the exponents inside. We've shown it all, we just haven't made it all big like this. Give it a gander, we'll do it together in a couple minutes.
Let's try that.
No. I'll take it home and I'll have it in the morning. I got Calc 1 in the morning at fucking 8 AM. I'll get in there all fucking
There you go.
fucking buzzing like a bumblebee. He's already set his pin down. Do you think I tricked him? Think he's gonna have the right answer or the wrong answer? We'll find out. Crafty Mr. Jones. That's not a saying. I don't know what I'm on you. It's not like I'm bored. I'm not bored. You guys are a pleasant class to interact with. Most classes, when if I ask what absolute value is. Most people aren't gonna answer because they're like, I don't wanna look stupid. I had 2 people blurting out the answer. It's fucking awesome. I didn't think anyone was gonna know. I thought I was just throwing it out there to see what was gonna fall out. All right, what's the first step? Someone help me with this.
2 times 4, 3 times 4. Yes.
So do the 2 times the 4 up here. And the 3 times the 4 up here. Is that what you're saying? What else? That's correct so far.
Same thing with the bottom.
What about the 2, -2 over there?
So negative 2 to the 4th.
Yeah, we're gonna have -2 to the, this is really to the first power, it's like doing 1 times 4. So we'll be -2 to the 4th. That's where I was hoping to catch them. Yes, Josue?
Oh no, I mean it's 16.
Yeah, -2 to the 4, power is 16. So that becomes 16 on top. 2 times 4 is 8. 3 times 4 is 12. All good. Did throw you off with the -2? I get a lot of people with that. A lot of people, they don't see the exponent, so they don't distribute it. They leave it alone. So that it's a trap. It's a trap. Have I asked this class how many of you have actually seen Star Wars?
No,
How many of you have seen Star Wars?
it's decent.
Oh, thank God! Yay! Most of you, only a couple people didn't raise their hand. I do this shit in like the stats class. Out of like 40 people, I'll get like fucking 12 people to raise their hand. And I'm like, God damn, you guys are fucking killing me. It's not that old. It's like the original is old, but there's plenty of Star Wars shit being released currently. The Mandalorian.
Yeah.
Or that there, Ashley, what's the chick one?
So good.
Ashoka. And then we've had Rogue One, and we've had like this bunch. Thankfully, it's a trap. It's from one of the old Star Wars. Which one?
A New Hope, I think.
Is it? Is it A New Hope or is it
Jedi.
Return of the Jedi? It's one of those two.
One of the ones.
Shit. I don't know which one it is. No, I think it's Return of the Jedi. I'm wasting enough time on this. Let's continue. Let's continue. One more topic and then do I have room on the page to do one more line? No, I don't. I want you to do -4 to the 0, and I want you to do -4 to the 0. Like that. Ooh, what did Mr. Jones do? Is this a brick? Are they equal? Are they not equal? So what does the 0 exponent do?
It's become 1.
It makes whatever it's touching equal 1. So 0 makes this equal 1. Here, the 0 is only attached to the 4. So this is -1. So the parentheses matter. When you've got negative numbers and exponents, watch for it. You ready for some more writing? Some fucking sentences, Luis? Are you ready? Tell me, are you ready? This is fucking exciting stuff. terms. Gotta give you some terminology, and one of the terminologies is actually the word terms. Terms are products of numbers and variables. And it doesn't just have to be one variable, it could be a bunch of variables together, one or more variables. And there can be exponents involved. 2 powers, exponents. For example, 3x plus 4y plus 5xyz. That's one term, that's the second term, and that's the third term. So terms are separated by addition and subtraction. That message. Well, Sway typed me. I don't know what he typed me about. That's all he said. And I don't know how old I was. 5 minutes ago. Who knew what? I must have. Oh, I asked if you've seen Star Wars. He said me. That's gotta be what he's talking about. All right, so these are like numbers and variables multiplied together. The numbers in front, these are called numerical coefficients. Or just coefficients. Because we like to shorten it up a little bit in mathematics. We don't have any long fucking really drawn out names for shit, do we? Coefficients, numerator. When top suffices, they came out with fucking numerator. So numbers they're called coefficients. That unfortunately doesn't have a short word for it. We don't shorten it to coefs. We just say, you'll hear coefficients. So these are terms. If we have something called like terms, these are terms with the same variables with their exponents. The only thing that's different is coefficients can be different. Or usually different. And now to the very name of this entire fucking section. Polynomial. What the hell is a polynomial? Polynomial is a finite sum of terms with non-negative exponents. You might see this as c to the 0 or c sub 0 plus c1 x to the 1 plus c2 x to the 2 plus c3 x to the 3 power. plus dot 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 going up to Cn x to the n. All of these C's are just numbers. All of the C sub I, for lack of a better word, are just the coefficients. In fact, as you're going through mathematics, you'll see this a lot, this I thing. It's called the index. I'm not gonna use it for a while again, so I'll mention it again when I bring it up again. It's just a way of saying a bunch of these are similar, but they're just slightly different. They're dependent on the position in their thing. And the only reason we started with C0 is because we kept it so that the number matched the exponent. I was wondering what you two were passing earlier. I thought it was like fucking breath mints or something. I'm like, what the fuck is going on up here?
I don't wanna keep pulling out pencils.
That is so fucking awesome. You still have a fucking regular pencil. Anybody else here got a regular, like non-clicky, not mechanical pencil?
I hate this.
Really?
I hate it.
Why? Why?
Yeah,
Is it the clicking sound or is it like the lead, or is it the lead breaking?
all of that.
All of that?
Just annoying in general.
I had to ask, it's a fun question. All right, so some more terminology here, because we know Luis likes writing sentences. The degree of a term. Is the sum of the exponents of the variables. You all right, Josue? You type yes, 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 yes. You're not just having a stroke on me, are you?
No, I just answered something that you said before.
Okay, just
You
making
just
sure.
answered it.
Gotta check, well, that was probably supposed to be a H-A-H-A-H-A. J is next to it, yep, that was supposed to be a ha 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 ha.
Laughing.
Alright, so like, if I've got like 5ab squared c cubed d. The degree on this term, the a has a 1, the b has a 2, the c has a 3. And the d has another 1. If an exponent is missing, it equals 1. So this is called, or this is I got 5 plus 2 is 7. This is a 7th degree term. We had degree of a term, so of course we gotta kick it up a notch. What's the degree of a polynomial? This is actually a very handy thing. Because when you know the degree of a polynomial, you know a lot of shit about it, as you'll find out as you're going through these classes. The degree of a polynomial is the highest degree of the terms. So up here. This is an nth degree polynomial. Because it went up to x to the nth power. Poly means many. We do have different names for when there's fewer terms. So when there's only one term. We call it a monomial. Like mono. Two terms. Is a binomial. Or the bi, that's two. Three terms. We call it a trinomial. What? You go, oh, really? Like you fucking just know this shit, right?
It's just given.
Four terms. What do you want to call it? No, this is where they just say fuck it. Polynomials from here on.
Oh,
I am really glad you just volunteered that shit.
it would
Because
make
if you
sense.
didn't, I was just gonna ask, what's the fourth term called?
It was-
There's always a clever person in the class. You wanna call it like a quadrinomial or some shit like that. Nah, they just fucking tap out at that point. We list polynomials in descending degree. Unlike what I did up there. If I had 7x plus 9x cubed plus 8x squared minus 1. The appropriate way to write this is you start with the highest exponent. 9x cubed plus 8x squared plus 7x minus 1. At least in English. We read left to right, so it's handy to know right away what the biggest term is. So we put it up front. This is a polynomial. Polynomial. Yeah, oh, I only got one more question, then I'm gonna let you go. Is x squared plus 1 over x squared a polynomial? Oh, he maybe fucking wrote down the definitions of polynomial, and I don't even know what it is. Let's go back and look what Mr. Jones said. Mr. Jones said polynomial is a finite sum of terms with non-negative exponents. The appropriate way to write this is with it as moving that up to the numerator as x to the negative 2. It's got a negative exponent, so no, it's not a monomial binomial, it's not a binomial. It was a dirty trick. And with that, if you are done writing and you have no questions, you are free to GTFO. If you guys want help on the weekend, I am going to be in the Mesa Center, which is the John Muir Building on Visalia campus on Saturday morning from 9 to 12. I'll send out an announcement. I'll be there, so if you're working on your homework or anything and you got questions, I'll be
So
available.
You said you're gonna be there at what time? Sorry, you can
Between
you
9 and 12 on Saturdays.
you can do that online too. You do that online.
No, I'm not gonna do it online. I'm probably gonna have a bunch of students showing up and there's no way I can manage the computer or doing it with the
okay.
computer also.
Okay, that's fine then.
If no one, I'm gonna take my laptop and if no one's there, I'll hop on Zoom.
Okay, got it. Thank you.
Okay?
Appreciate it.